The topic is understanding the concept of pods and deploying multiple pods with single node architecture on Minikube for a Node.js application that is resume matcher. Let's begin. First, let's understand why do we need pods? Why is a Docker file not enough? And why do we need pods over container? First, we must know that Docker file has its power and benefits. Also, containers also have their powers and benefits. They do their purpose and their work. However, Docker file cannot scale up the application, scale down the application, cannot create replicas. However, Docker Swarm, etc., which can do that, but Docker file, in short, containerization concept cannot fulfill creating replicas, healing, auto-healing, scaling and scaling down of the application. So to do that, we need a concept that is Kubernetes orchestration. So that takes the concept of containers and it manages the orchestration of scaling down, managing the health and life cycle of those containers that are now wrapped around a pod. So I hope it makes sense. So now what is a pod? Pod simply is a wrapper over your container. So we know that we can create a container by creating a Docker file and building an image around it. That's great, but it cannot be scaled up, scaled down. It is a static. And if it is deleted or it has some issues, your data will be lost. So in order to fix those problems or issues in a Docker file or in container or containerization, we use the concept of pods in Kubernetes. So you would be having your Docker file for your application while you created a container of it. That's great. So you would take those information and prepare a pod deployment file, that is deployment.yaml, that's whose only purpose is to manage the lifecycle of your pod. So while you create the deployment.yaml with respect to your Docker file of your application that was containerized, now your container has some powers, that is scaling down, healing, auto healing and replicas of those pods. In deployment.yaml, we specify information with respect to our Docker file that is used to scale up, scale down, heal and replicas or to replicate the pods. Now let's understand with respect to my application, that is resume matcher, how I managed to pull off single node multiple pod architecture to deploy this application which was running really fine on Minikube. First, you can observe the Kubernetes folder inside the application folder of mine, that is resume matcher DevOps. We can observe that there are certain files, that is configuration, YAML, DB secret, deployment, API secret, CXID, Ingress, PostgreSQL admin, PVC, Postgres.yaml, Postgres PVC new.yaml and service.yaml. So these were the YAML files that I created in order to manage the working of my application. But ConfigMap.yaml, I use this to map specific sensitive information like passwords, API keys that I don't want to hard code that into the deployment.yaml. So it is like a secret management thing. So configuration management or configmap.yaml will have all the information regarding the API keys and it would be having a certain keyword that is used in the deployment.yaml that maps to this config map. So that would have some secrets API keys for my application to run. A DB secret, it is a database secret.yaml file. In this, I have created a secret file for storing the password for the database access of this application. So deployment.yaml has the purpose of scaling and all these features of the Kubernetes for my application. And Google API secret.yaml is also a secret file to store API key as a secret, and also same for CXID, or that is some configuration files to work my application. It was secret file. And Ingress.yaml, this is for my future deployment if I would be doing or deploying it on a host name or DNS. So Ingress would help in achieving that to map DNS with respect to the application. So pgAdmin.yaml, it is for PostgreSQL.yaml. I used database, that is Postgres. So that is YAML file to configure the Postgres admin access. And pgAdmin PVC is persistent volume with respect to Postgres admin access. Both pgAdmin and pgAdmin PVC YAML files are to manage the access of Postgres admin UI and persistence volume to access that UI or the site, which I would be doing later in this video to access the database of this application. Just know right now that pgAdmin and pgAdmin PVC are used to help me have storage and configuration to access UI or user interface of database Postgres and to see the database visibly in the UI format. So these two would help me achieve that. So now it is Postgres YAML and Postgres PVC new.yaml. So these both are to store actual persistent volume information and configuration of Postgres database information and data that is stored inside the database. So admin was to access the UI, and Postgres PVC and Postgres YAML are used to actually store that information inside the database of Postgres. PVC or persistent volume is used to not lose the data. If it's persistent volume, the data would not be lost and it would be stored. Since pods are temporary, they can lose data. So unless we use PVC or persistent volume claims, that data cannot be lost. So I use persistent volume claim YAML file to store that database information. And finally, it is service.yaml, while deployment.yaml is used for having or providing scalable, healing, replicas, all those Kubernetes features, while service.yaml is used to create stable IP, load balancing, and to expose the application. We must know that pods are temporary and their IP addresses can change every time they are recreated. So we need a service.yaml to act as a permanent bridge. So service.yaml would assign a single cluster IP address or DNS name that stays same even if all the underlying pods change. It is used in load balancing. When traffic hits a service, it would route to one of the healthy pods matching its selector labels. Basically, it is to access your application on ports. So services would give you information. So in service.yaml, we will fill information with respect to our application and its information. For example, my application is DB, Postgres, and application itself. So there are 3 pods that would be running. It must have some ports to access that information so I can use my application. So in order to do that, we need service.yaml to map those ports. So deployment.yaml would be used to have Kubernetes features of scaling, etc. And service.yaml is used to map ports to access. So my application has Postgres UI database, so I can log into the UI of Postgres admin and see the database. So I would also need to have service.yaml that mentions this information to map ports to access this pgAdmin, and also my application in itself. So this needs ports. So if my application needs to be accessed, it must be in certain ports. As pods can change its IP addresses each time it is created or restarted, we need service.yaml to have a stable IP address that is like a bridge so we can access our application easily and efficiently. So that was about the YAML files I have implemented and created. Now let's understand deployment.yaml in detail. So YAML files are always in a YAML format, that is API version kind deployment, and I named it resume matcher, and app is resume matcher. I want replicas, that is 2. I used Postgres version 15 as an image for my containers and its database, and we can see image name, that is Kaif Mohammad Khan 123 / resume matcher DevOps. So that would be the constant name of the image pushed on the Docker hub. So it would pull that image with this name in it. Container port is 3000. We can see environment, that is Google API key. So this is a secret key or API key that I have stored in another YAML as a secret. We can see secret key reference, that is Google API key, which I showed before, like Google API key was a YAML file. You can see key, that is API key. And now it is Google CXID, same secret key reference, Google CXID, which I showed you, Google CXID YAML file to reference CXID as a secret. Now DB type and DB user are both database related information. For DB type, I have used Postgres as I mentioned, and for DB user, it has secret key reference, that is DB secret. In that DB secret, I have created password and username for my database for the database of the application, and it has Postgres user DB password. And for secret key reference, DB secret also has Postgres password. So one more thing to remember is Postgres is a UI. I have used Postgres UI to access the application database. So it has two database related information in this deployment.yaml. For a simple DB type, it is DB secret that has information for actual database without UI in it. So actual database has certain password in it. So that also has a DB secret YAML file that has that information. Also Postgres is the UI related to access that raw database. So that also has username and password. That is also kept in a DB secret YAML file. And DB host and DB port is 5432. And resources, it is CPU 100M, memory 128 MI, limits 500 CPU and memory 512 MI. And volume mods is uploads and it is app/upload, name logs, app/logs. So this would store the uploaded resumes information. So whenever a resume is uploaded, the user's information, that is name and their email, are stored in the database to know who has entered or who is accessing and utilizing the application. So it is named uploads. Now service, that is resume matcher service, it is on HTTP with TCP protocol at port 3000, target port 3000, node port 30080, that is type node port. That was about deployment.yaml, which is used for having Kubernetes benefits, that is deployment, replicas, scaling, healing, all these features, which was not utilized or not accessible in a single container or in containerization concept. So it is a concept container orchestration in Kubernetes where we have pods that has this deployment.yaml, which allows us to have these production grade benefits for our application, that is scaling, healing, replicating. So that was deployment.yaml. Now let's understand service.yaml. I've mentioned that there are certain concepts in a YAML file or in Kubernetes that are really important for our application management. One of them is service.yaml. Some others were PVC for persistent volume, Ingress for DNS, secrets for secret management, configuration map for managing API keys and secrets, etc. So one of the most important is deployment and service.yaml. Now let's understand the purpose and explanation of service.yaml. As I mentioned before, service.yaml has a purpose to map ports of the containers that would be running. For example, if my application has containers for PostgreSQL UI access to have visualization of the database, so I would have to create a service.yaml, and inside that I would need to specify ports and information directing towards deployment.yaml and all those other YAML files, so application would be accessible on those specified ports instead of getting a random or other ports every time the pod or replicas are created. So if my application has Postgres UI database access required to have visualization of database, so I would need to map some ports in it in the service.yaml. Also for accessing the application in itself, we need to map ports. So service.yaml acts as blueprint to have stable IP addresses within the range specified in this service.yaml. So first is Postgres deployment plus service. As mentioned, I have used PostgreSQL as a database and it has the UI or the website pgAdmin, so it must have certain ports to access that website or that UI of Postgres admin. So this deployment with respect to Postgres is required. So replicas is one, labels are DB, that is database, containers that has the name Postgres, image version is Postgres 15, the port mapping is 5432, environment is Postgres user, value resume, password, and Postgres database name, that is resumedb. These information are used for database access. And API version 1 kind service that is mapped to port 5432, target port 5432, and that is of cluster IP. Also, it is mounted to the path var/lib/postgresql/data. Now, resume matcher deployment service. It has name resume matcher, replicas are 2, labels are resume matcher, and container is resume matcher, and image is, as I mentioned, that image pushed on Docker Hub would be named Kaif Muhammad Khan 123/resume matcher DevOps. So it has this name. So container port is 3000, name, Google API key, all these information are in the secret, also mentioned in the deployment.yaml. And database, username and password information, and resources, that is request with CPU 100M, memory 128 MI, limits are 500 M, and memory, that is 512 MI. Volume mounts are named uploads, app/upload, logs, app/logs. Now we are matching that as a service, that is resume matcher service with name resume matcher with label resume matcher, selector app resume matcher, ports HTTP TCP port 3000, node port 30080, type node port. So that was about deployment.yaml and service.yaml and its use case and how it is useful with respect to my application. Now let's understand the working of this process. So first I headed into the git bash terminal and switched the directory to the application directory, that is resume matcher DevOps, and I performed minikube start and it started successfully. Then I performed kubectl get nodes to get information on nodes. So it's at minikube, that is a name, and it showed status ready. Role was control plane, that is master node, and it had version 1.35.1. Then I switched into the Kubernetes directory performing cd Kubernetes, and I performed kubectl apply -f base dot to apply changes and to configure the YAML files that I created, which I mentioned before, like all these YAML files, secret files, deployment, etc. To apply and configure this, the command is kubectl apply -f space dot. This command would apply the apply feature to all the YAML files it finds inside of directory or folder. If I would not perform this command, the other command would be specifying each YAML file and then performing the apply. So to save time, I perform this kubectl apply -f space dot that would apply to all the YAML files inside the folder, that is Kubernetes. After its successful configuration, I performed kubectl get pods to see the availability and status of the pods. One more thing to remember here is if you do not perform the image pull with respect to your application post in the Docker Hub, your pod status might show errors with respect to image pull. So to fix those and to have your pods running successfully without any errors, you must first build your image, a Docker build, and push that image to the Docker Hub with respect to the tags specified in the deployment.yaml and service.yaml, and then pull that back again. So your pods and the minikube also would have that image as a reference to run these pods. If it would not be the case, then it would show image pull and some other errors as well. So I performed this command before, that was pushing the image, building the image, and pulling back that image with respect to the name I specified in the deployment.yaml and service.yaml, that was Kaif Mohammed Khan 123 / resume matcher DevOps. So after I performed all this, I performed kubectl get pods, and it showed name of the pods that were running successfully with the status running. As I mentioned, I performed replicas 2 for resume matcher, so it shows 2 for resume matcher and single replicas for pgAdmin and for single replicas for db. After knowing pods are running successfully, I performed minikube service space resume matcher service to access my application. After performing that, the resume matcher service, that is the application, was running on the port 55471. As you can see, it was successfully running, and I performed the upload of my resume and it showed results that were of a successful match. Then I performed change directory to the Kubernetes, and I performed minikube service pgAdmin -service to access the pgAdmin or simply the UI of the database. After that, it was accessible on the port 54186. So this is the pgAdmin or Postgres database admin UI. I performed the login with respect to the credentials that I had specified in the YAML files. After login, I clicked on add new server and I filled information name in the general, and in the connection section I filled the information with respect to the information that I specified of my database. That includes passwords, ports, the database name, username, etc. that were specified in the YAML files. So it would pull all those information and show me here in the Postgres admin database UI. So after successfully configuring all those information, I performed the upload of the resume again to check the availability of database and to see its workability with respect to the PVC and all those YAML files that I applied. And I performed access to my resumes table in the pgAdmin. The database information with respect to the user that was uploading the resume was successfully visible. For example, I uploaded my resume and it showed the name Kaif Mohammed Khan, and it also showed the location as well, but it uses the resume parsing algorithm which can't be 100% accurate, so it is still better than nothing. to show no results, but I'm convinced that it has at least showed the name clearly. So it showed my name and it showed clearly the email of mine. Also showed skills it passed or performed algorithms to know the skill set of this resume, which was engineer AWS cloud, and it also showed timestamp of when it was uploaded. So that was about this video. I explained you the concept of pods and why it is used and why it is different from containerization, and how orchestration manages all the features of Kubernetes, that is healing, etc. And we understood the concept of YAML files and different types of YAML files with respect to the application you are running. And I showed you how I performed admin database as well as accessing my application, and how I successfully managed to run this application as well as the database on single node multiple pod architecture, performing replicas, memory, auto healing, all these features with respect to the pod. So that is it for the video today. Thanks so much for watching. Have a great day. Bye.